Hello and welcome to Cannon County High School Algebra 2. Yesterday we talked a little bit about a new statistic called variance, and today we're going to talk about variance's little brother, standard deviation. You actually use standard deviation a lot more than you use variance, but you need to understand how to calculate the variance in order to calculate the standard deviation. And so today we're going to talk about standard deviation and where we can use it. We're not going to do a whole lot of story problems with it just yet. We're just going to learn how to calculate it. And we'll kind of, we'll get into the where you use it in later lessons. So, Mr. Lyon, I'm going to have you supervise us over here. And let's talk about what is standard deviation. This is not going to be difficult because you know variance is sigma squared. Standard deviation is sigma. And so how do you go from sigma squared to sigma? You take the square root. So really the standard deviation is just the square root of the variance. That's all it is. And in today's lesson, I am going to ask you to do some calculations on IXL, but just like yesterday, I'm not going to ask you to get up to 80% on those. Just do a couple of them. This one is actually going to be DD.6. And basically what you do to find the standard deviation is you calculate the variance and then you take the square root. So let's take a look at what that looks like. If you didn't watch yesterday's video, you're going to need to go back and look at that. But this is the example we did yesterday. This was the formula that we used for the variance. You add up the difference between each value and its expected value, you square that, and then you multiply by the probability of each value. And so what they're going to do on the IXL on DD6 is they're going to give you just a probability distribution, just this amount right here. So they're going to tell you an X, and what's the probability of each one of those happening. Then you will calculate what X times the probability of X is. So in this case, you take 3 times 0.6 equals 1.8, and so on and so on. Then, and this is the part where you have to actually do a little thinking, you're going to take X minus the expected value of X. Remember, we figured out yesterday the expected value by adding up each of these, 1.8, 0.8, 1, and 0. We added those up and got 3.6. So for this column right here, we took each value of X, subtracted 3.6 from that, and then squared it. So 3 minus 3.6 squared is this. 4 minus 3.6 squared is this. And so on and so on and so on. Okay? Once you get that column, then you multiply that column by the probability, which is this column. So these two numbers multiplied together give you this number. These two numbers multiplied together give you this number, and so on. Once you get this column written out, you just add them together, and that's the answer. That's the variance. Okay? To find the standard deviation, then, all you do is take the square root. So what's the square root of 0.64? It's 0.8. So that's a lot easier than what we did yesterday. Yeah, once you get the variance, finding the standard deviation is really easy. You just take the square root. So the standard deviation is 0.8. Okay? Well, what is standard deviation? Standard deviation, kind of like variance, is just a statistic that we use to figure out how spread out is the data. Okay? That's really what it measures. So let's just do a little example. Let's say that you went out to John Bragg Highway, and that, let's see, I'm going to write this down. We're out here on John Bragg, and you know which highway that is, right? That's 70S. That's the road going to Murfreesboro. And let's say you, your friend, the police officer, let you borrow his speed gun. So you're going to figure out how fast each car going down the highway is going. So you're camped out on top of the hill, and you just take the first 10 measurements. And the first car going by is doing 72, and then you got another car doing 64, another car doing 75, 71, then you had a 70, a 70, a 65, somebody's actually going a speed limit, let's see, 78, 64, there goes grandma doing below the speed limit, and 72. Okay, so let's say out of 10 cars, those are the speeds. And you want to figure out how spread out this data is from one day to the next. So what you would do is you would calculate the standard deviation. Now you need to know how to calculate the variance in order to find the standard deviation, but what you'll find is that standard deviation is used more often in the real world than variance to tell how spread out the data is. Okay, and what you would do first is find the mean, so you add all these up and divide by 10, and the way that you write mean in probability is you put an X with a little line over it. So for this one, I've already done the math for you. I'm going to tell you what the math is. We did all the math yesterday to figure out variance. I'm not going to show you how to do that again. I'm not going to bore you with showing you how to do that all over again. But the mean is 70.1. So on average, cars going down the road on John Bragg Highway are going 70.1 miles per hour. What we want to figure out is how spread out is this data? And the standard deviation helps you do that. Now, first you would calculate the variance, and I've already done that for you. It's 19.49. All right, again, I'm not going to show you how to do this. We did that yesterday. Now, what is the standard deviation? The standard deviation is just the square root of this number, and I've already calculated that for you. You just take the square root of 19.49, and you get 4.4. So 4.4 is the standard deviation of this data. Why do we care about that? Because once you get the standard deviation, remember yesterday we talked about the fact that a lot of things are going to follow what's called a bell curve. And this is really no different. Because whenever you, remember we said the mean is right in the middle. So the mean right here is 70.1. All right, if you were to figure out the speed of all the cars going down John Bragg Highway, some of them would be going really, really fast. Some of them would be going really, really slow, but most of them are kind of in the middle, and they follow what's called a bell curve. The standard deviation is something that helps us figure out how spread apart that is, because within one standard deviation of the mean is 68% of the data. What does that mean? That means if we go one standard deviation in this direction, let's say right about here, that's one standard deviation away from the mean, and we subtract one standard deviation the other way, let's go in that direction, negative standard deviation, that means between here and here is going to be about 68% of the data. Okay? If you go another standard deviation from the mean, if you go all the way out here to 2 sigma, and all the way out here to negative 2 sigma, well, what happens there is from negative 2 sigma to positive 2 sigma is 95% of the data. The ACT test loves to give you questions where they ask you what is the probability of something within such and such standard deviations of the mean, because they expect you to know that 68% of the data is between plus or minus 1 standard deviation of the mean, and 95% of the data is plus or minus 2 standard deviations of the mean. Okay? So if you were to do this, you could say, well, 68% of the data is going to be 70.1 plus 4.4 or minus 4.4 miles per hour. Okay? So let's look at another example. Same idea, another example. Let's say you're working in a factory and you are working quality control in a factory. And let's say you are working at an automotive factory and you're making car parts. You're making piston heads. So a piston, the head of a piston is round, of course, so it's going to be a circle. And let's say that the diameter of the piston head that you're making is supposed to be exactly 5 inches. Okay? So the machine that you're using to make these piston heads is supposed to produce them to exactly a diameter of 5 inches. And let's say that on this machine, you want to obviously reject any piston heads that are outside of a certain tolerance. And let's say your boss tells you that you are to reject anything, so anything anything that is greater than plus or minus 2 standard deviations from the mean, you're going to reject. So you have to calculate. You would have to take a sample of all these piston heads, measure them, figure out what the standard deviation is, all right, and then reject anything that's either above 2 standard deviations from the mean or below 2 standard deviations from the mean. So what does that mean? Let's say you calculate the standard deviation to be 0.001 inches, 1/1000th of an inch. After you look at all of these, you say it's 1/1000th of an inch. So you would have to set up the machine to reject anything. If we said 2 sigma is what we were looking at, that would be 0.002. So that means if the mean is 5, that's what we're shooting for, then 5 plus 0.002 is 5.002. And 5 minus 0.002 is 4.998. So you would say you are going to accept anything between 4.998 and 5.002. And you would throw out any piston heads that are outside of that. And because we decided to go to 2 standard deviations, that means that 95% of the piston heads will be accepted. Okay? Now you might, again, depending on how much quality control you want on this part, you might say you want to go to 3 standard deviations and so on. But that's the way, I just noticed that I misspelled quality. There we go. Quality control has an L. Who knew? I'm not good at spelling. I'm not that good at math either, but anyway. Let's see, where were we? Yeah, standard deviation. So that's really basically how you use it. And we're going to be doing a lot of examples later on that use standard deviation in a lot of different contexts, not just making automotive parts, not just figuring out the speed of a car going down the highway, but there are lots and lots of things where you want to figure out how spread out is the data, okay? The height of people in your class, all kinds of different things. So anyway, what I'd like you to do, again, is go to DD.6. They're going to ask you to calculate some standard deviations using the same method that we did yesterday. Just calculate the variance and then take the square root. That's the only extra step. Do a couple of those just so you're good at it, and eventually we will do some problems where we put all this into practice and it'll make a little bit more sense. So thanks for watching. If you have any questions, put them down in the comments and I will talk to you tomorrow. Bye.